Hi everyone, in this video I'm going to look at and hopefully repair this this basically a water pump thing. It's actually my brother's and it's acting up. He's got another one and this is the spare, but hopefully I can repair it. So the description of the problem is, he said that it just cuts out, so you can turn it on and the pump seems to work, but then after some time it cuts out, and apparently the temporary repair is to kick it. So obviously if you kick it, the effect it has is it moves the internal parts. So if moving the internal parts temporarily fixes it, then that tells me that something's loose. But anyway, it's a water-based product, if you know what I mean, so it's likely that the insides are going to be corroded or wet or something, or maybe there's a leak. So, I don't know. Whatever the problem is, I'll have a look and see what we can do. Right, so I'll try and disconnect this thing to start with. Okay, will it come out now? There we go. Okay, so we can finally get rid of that thing. Now you can see that there's a seal on it. And there's the hose, so I'll just put this to one side. Okay, so I can get to it now and find out what's going on. So to start with, there's a plug here, or a socket actually, a socket, and it's a 250 volt socket, it looks like to me. So to start with, it goes through this wire here to the switch. There's a little switch here. Then from the switch it goes down here to what appears to be the motor. Right, so then from the motor it comes back out and it goes to whatever that is, and it goes from whatever that is to something that was on there, and therefore complete the circuit. Now at the same time, this was plugged in, and this goes to the battery. So what's this doing? So yeah, the power goes straight to the battery and comes back out the other end. I assume that's a 12 volt battery, and there's like a charging unit there. Now the charging unit will be a step down transformer with a rectifier. Okay, so there's one part of it. So let's see what this is. For battery sprayer, Cobalt AG supplies. It's a 9 amp hour, 12 volt battery, and to me this looks like sealed lead acid. Don't expose the battery to fire or water. And you can see it's soaking wet. Anyway, that won't matter too much because it's a sealed lead acid battery. It is actually a funny looking sealed lead acid battery, because I've never seen this before. So I need to take that off and find out what's going on. Now, I need to be especially careful here because although this is 12 volts, it's wet, so okay, that's corroded like crazy. That's the first problem. So I assume this thing is completely dead. Right, so the terminals just come straight off it, so that's a problem. Now this is interesting here, this thing. There we go. Okay, yeah, it's a sealed lead acid battery. So what happens is that these will come off, and you can top the water up inside it. But primarily the idea of these are that when this thing gets charged up, the hydrogen comes out of this hole, and this whole thing is a pressure system basically. So if I have a look in there, I don't know if you'll be able to see it on camera. Actually, I can't even see it with my own eyes, let alone the camera. But in there should be water. Now, I won't be crazy because it's a sealed one. There's like tissue in between the plates. But anyway, I would have thought you'd be able to see a little bit. So, what the hell? Anyway, I think what I'll do is I'll check the voltage of that battery, and we'll see what sort of condition it's in. Okay, 11.3. Okay, that's not terrible. That seems healthy to me. Let's put that back on there. I'd probably get one of those little, I can't remember what they're called now, like a little squeezer thing, and squeeze a few drops of water in each one. But anyway, for now, whatever. I'll just close this off. Okay, and all that stuff's off now. So I need to take this pump out now. So there's the motor, that is the pump mechanism, so water comes in there and out there. That appears to be some sort of safety cut-off switch. So electronically, what seems to be happening is that this is the plus, goes through here, this switch seems to be on or off depending on how it's configured, I don't really know. Then the power comes out of here to the motor and then back out. Okay, what I'm going to do now, I've got my power supply unit here, and this can let me have any voltage I want, up to say 30 volts, and I can have any amperage I want too. This is a 12 volt motor, or a 12 volt pump, and I'm going to test it out now. I mean, there's terrible corrosion throughout the whole system. You can see it on the battery and you can see it here. So yeah, corrosion, loose wires, etc. Anyway, I'm going to try this pump out now, and we'll just be sure that this pump actually works. Right, I've took the pump off, and I just want to make sure that this is working. So I'll give it some voltage, and it is working. It sounds a bit rough though, but it is working. So we can pretty much rule that out as being a problem. Okay, so I've given it 2 volts, which isn't really enough, but it'll do. So what happens is that the water comes in through here, it seems, through this pipe here. Comes through here, which I'll explain in a second, and then it goes through this little channel. There's a sealed thing on there, so like the water comes in through this one here, goes through the channel, and then it goes to this pump area here. And this pump seems to pump water through, and there's like a valve there, and then over here when it pushes it through, when it pushes the water, you can see the valve there, and it springs back into place. So it sucks it through. There's a little spring loaded thing here, actually it's that way, I can get that in, and then after it's done that, it pumps and then pushes it through there into here. So yeah, that's how it works. So the motor's working, and this doesn't appear to be blocked or anything, so I assume when I put this back together it should work fine. So now I need to power it, and I've been using this to make it portable. It's just a lithium-ion battery pack that I made, I can change the voltage to anything I want because I've got control over the cathode and the anode. So I can go up to, I don't know, 15 volts or whatever, but I'm not going to use that. I'm going to keep it simple and use my power supply unit, which is over here. So the power supply unit is pretty good because you can actually choose whatever voltage you want and also limit the amperage. Anyway, let's go back over here. I'll zoom out a bit more. Okay, now I want to connect this thing up obviously, and I'll give it a small amount of voltage. I don't want this thing to go too crazy. So, right, now I need to be mindful of this. This has to be primed, and I have primed it. I've forced a load of water in it, but I'm not exactly sure how this is going to work. So this may not work straight away. We'll see. There we go. So you can see that it's pumping water out now. And so it's working. You can see that there's like an inlet pipe over there. It goes through here. This works as magic and pumps the water through a little I don't know, these little cavities through here and then back out. So the pump's working, so we know that the pump's working, so that's good. That's one thing ruled out. Now, just while we're here, my brother asked me via Facebook earlier. He said, is there any way you can control the speed or the flow of water? And there is. And basically the speed of the water, or the speed of the pumping, is controlled by the speed of the motor. So the faster the motor goes, the more water gets pumped, and the slower the motor goes, the slower water gets pumped. So right now, for example, the voltage is 12.9 volts, and the more voltage I give it, the faster it will go. So if I just increase the voltage, there'll be more water coming out and more pressure. If I lower the voltage, less water will come out until you can see here this is 5 volts and it's just dribbling out. So if I do, let's go lower. Yeah, if I go too low, you'll probably get an airlock again. That's 3 volts. Yeah, it kind of stops at about 3 volts. To answer the question, yeah, we can control the speed of the water. We control it by changing the voltage. What you have to do is, there's actually 2 ways. There's using a voltage regulator, or there's using a switch mode power supply. So with a voltage regulator, what happens is that the 12 volts comes in, and effectively it wastes whatever you don't want. So if you want half speed to save water or whatever, you probably want to give this, say, 9 volts instead of 12 volts for half speed. What that means is that in order to get that, the voltage regulator would have to burn off 3 volts. Now the other way is the switch mode way, and the switch mode way is a bit more expensive and it's a bit more messing about, but it should work pretty well. So I'd have to show you one of these. The one I'm thinking of is called LM2598. Let me see if I've got one around here. Actually, the module was not 2598, it's LM2596, and it's this module here. This is called a buck converter, and a buck converter gets a voltage and steps it down into another voltage, and it does this via, or this particular chip does it via switch mode. So what it actually does is, instead of burning it off, it switches it on and off rapidly, and then smooths out the resulting voltage. And that's quite clever. That's how it works. So what I'd have to do here is supply the 12 volts here, and then the output here would go to obviously power the motor. Now the thing is with this is supposed to be really a fixed thing. You're supposed to set this potentiometer here, or variable resistor, and then this thing works. So if you set that to a certain level, maybe this could be 12 volts, and that would output 6 volts. And you're supposed to just leave it in place, and that's it. You've got a permanent 6 volt power supply. But we don't want to do that. What we need to do is, I would imagine he needs the ability to twist something, to twist a knob or whatever, to try and get this thing to work to the voltage he wants it to be at, or the speed he wants it to be at. So what we'll need to do is replace this potentiometer here. I know this potentiometer basically goes to the control circuit, which controls the voltage via this chip. So if I get this potentiometer out and get a matched resistor of the same the same resistance or ohms, and put it on a lead or something, or on the side of the actual case, that should work.